address is in a particular locale or region. It's on a particular network. And then it's an actual host or an apartment or home on that network. So the IP address here is really two parts. It's the network and then the actual node or host on that network. The laptop, the workstation, the PC, the server, the printer, whatever. Now, here's the tricky part. How do I differentiate between what part of this is the network and what part of it is the host? And nowadays, with this particular 32-bit address, realistically, any one of these octets, this could be the network, or both of these could be the network, or all three could be the network nowadays. We need some kind of mechanism in place for the computer to know what's the network, what's the host. It also helps the network engineer to know that information as well. Let's talk about that next. It's really important now to look back a little bit of history. Remember that the people that were responsible for putting the internet together and coming up with this scheme of logical internet protocol addressing of a 32-bit number. You know, the internet was being used for research and for government uses and basically research facilities, colleges, universities. They really didn't even imagine the World Wide Web at that point, or they figured by that time some new addressing scheme would come about, but it really never happened. And of course, we're dealing with 32 zeros and ones, so obviously there's a finite amount of addresses that can be available. So what they did was to kind of help this process along is they broke up this string of 32 bits into what are called address classes. And within that IP address space of those 4 octets, you've got 5 classes. Class A, Class B, Class C, Class D, and Class E. And everything really kind of falls upon that first octet range. If we go back and look at our IP address, it's that first octet that helps determine which class these IP addresses are in. Now realize that in the beginning, these Class A addresses were all given out to the big kind of backbone companies of the internet. And then along came other companies like Microsoft, and they started grabbing up the Class B addresses. So there really aren't a whole lot of addresses left. As a matter of fact, if you go to a service provider, an ISP, you're probably going to get what's called a Class C address. And then you've got Class D and Class E. Class D is used for multicasting. Again, multicasting is really beneficial to sending information out to a group of people on the internet and addressing them as a group. For example, if you want to do video streaming or you want to do web-based training, things like that. And then E is for experimental. We're really concerned with these first 3 ranges, A, B, and C here. And it really gets down to the number in that first octet. So if the first octet starts with a 1, is a decimal between 1 and 127, then it's a Class A address. As a matter of fact, it's going to be between 1 and 126. Technically, this says 127, but notice here it says the number of networks is 126. Why is one of them left out? Well, because the 127 network is actually used for as we'll see later on, kind of a troubleshooting address. 127.0.0.1 is used as a loopback address. It's used for testing your local system. Now, how many octets are set apart to represent the network? Well, 1. Let's take a look at what I'm talking about here. Here's a Class A address. Why? Because the value of the first octet falls between 1 and 127. It's 12. So, according to the specification, the first octet is the network, and the remaining 3 octets, or 24 bits, represents the host. So, as you can see here, with a Class A address, I've only got a handful, 126, potential networks. But within each one of those networks, I can have a whole heck of a lot of hosts. 2 to the 24 power host. That's a lot. Now let's go back and look at that diagram real quick. It shows you here, since you're only using the first octet to represent a Class A network, that gives you the potential of 126. Again, we can't use 127, and it gives you per network. So for each one of these 126, let's say it's 126 different companies, different large corporations, each one of these corporations can have 16,777,214 hosts or nodes per network. That's a lot. Now, all of your modern operating systems and most of your applications can look at the value of this first